Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions from May June 2023, Paper 2, Variant 2. In this lesson, we will try to cover all the remaining questions about mechanics from this paper. And we will discuss these questions in detail so you can improve your conceptual understanding of ES physics, and also you can have better understanding of these questions. In order to get maximum benefit from these videos, always pause the video, do questions by yourself, and then compare your answers with my solution to get maximum benefit out of these videos. And this is a practical way of learning from video lectures. Let's study together, let's improve together. Question 2, part A says, state what is meant by the center of gravity of an object. Center of gravity of an object is the point where if we apply a single force, we can balance that object. And that point is called center of gravity. Means at that point we can consider whole weight of the body is acting. For example, if I look at this marker, you can see it has mass. If I look at this part of the marker, it has certain mass and its weight is acting down. Here weight is acting down. I can take the next part of this marker, certain weight is acting down, and all over this marker. But there is a one special point on this marker where if I apply a single force upwards, I can balance this marker, and that point is called center of gravity. Or for this object we can also say center of mass. Now let's try to find out that point where we can apply a single force and we can balance this marker. So if I apply here, I cannot balance. If I keep sliding my finger, I will reach at one special point, and that special point is somewhere here. So I can balance this marker with one single force, and at that point is center of gravity. So the center of gravity of this marker is lying at this point because I can balance this one with one single force. So this point we call is center of gravity. Let's try to understand this one with the help of this figure as well. So here I have drawn this figure and I will explain you these points again. So first case, I assume that I take only this part of this meter rule. It has certain mass, so it means there is a certain weight that is acting down. And if I take the next part of this meter rule, let's say this part, there is mass, so there is a weight, and I can take next part, there is mass, there is a weight. I can take next part, there is mass. In this piece of meter rule, it has certain mass, so there is force of gravity on that. I can take next part, so there will be force acting downwards. Here force is acting downward, here force is acting downward, weight, and here weight is acting downward. And all these forces I can replace with one single force. Means at this point, if I apply one force that is equal to all these forces, I can balance this one. And that point where I apply one single force, that point we call is CG, that is the center of gravity. Or we can say in this case that is also center of mass. A beautiful point, a special point, very important when we manufacture something or when we design anything. Center of gravity is very important point. Let me show you the answer, how you can write down your answer. So in your answer you can simply mention the point where all the weight of the object is considered to act or is taken to act. That point is center of gravity. Part B says two blocks are on a horizontal beam that is pivoted at its center of gravity as shown in figure 2.1. Part B1 says by taking moments about the pivot, calculate tension T in the string. So for this question, simply we need to take moment about this point and we need to calculate value of T. So if you look at moment due to the weight of this block, this moment has to be counterclockwise, and moment due to weight of this block, this one has to be clockwise. And tension is acting at an angle, so tension has two components, so we can resolve into two components. It has one horizontal component and it has one vertical component. moment due to horizontal component has to be equal to 0 because this component of the tension is passing through the pivot, so no moment. But there will be moment due to vertical component of tension, and this moment has to be clockwise. Now simply we need to equate, because in this case beam is in equilibrium, so the net torque has to be equal to 0, or simply we can say clockwise counterclockwise moments has to be equal to clockwise moments. Clockwise moments means sum of counterclockwise moments has to be equal to sum of clockwise moments. Counterclockwise we have 54 and perpendicular distance is 0.45, and moment due to 2.4, this is clockwise, so we have 2.4 multiply by the perpendicular distance between pivot and the force, that is 0.95. And next one we have vertical component of tension, so this is T sine of 30 degrees, so we can write down T sine of 30 degrees, and the distance of this one is 0.35 plus 0.95, so this is 1.3 meters. Now simply we need to solve for T. If we solve this one for T up to 2SF, our answer will be equal to 34 newtons. So our final answer is 34 newtons up to 2SF. Up to 2SF, because the given data is up to 2SF, so our final answer also should be 2SF. And this question has 3 marks. The first mark you will get if you have written C, if you have written this part, you will get 1 C mark, and second C mark you will also get if you have written this equation, and the last mark is the answer mark. If you got the right answer, you will get 3 marks for this question. Part 2 says the string is cut so that the beam is no longer in equilibrium. Calculate the magnitude of the resultant moment about the pivot acting on the beam after the string is cut. So now in this case this string is cut, so no more force by the string on the beam. So in this case we have one block that is placed here, another block we have that one is placed here. So simply we need to calculate resultant moment in this case. So simply we can say resultant moment. Moment due to this block will be counterclockwise, moment due to this one will be clockwise. And counterclockwise moment we will take positive, and clockwise moment we will take negative. And sum of these moments is equal to resultant moment. So moment due to this block will be equal to 54 times 0.45, and this one has to be positive, and moment due to this small block has to be negative because this is clockwise, so we can write on 2.4 here, and this is multiplied by 0.95. Now if we solve this one, our final answer will be equal to 22 newtons meter, and this one is counterclockwise. So this is our final answer, and this question has only 1 mark. If you have got the right answer, you will get this mark. Part C says the beam in B rotates when the string is cut and the small block of weight 2.4 newtons is projected through the air. So it's simply, first of all, we have the block like this. It was tied with a string, and when the string is cut, this beam rotates like this. It rotates like this. So this is what is happening in this case. Figure 2.2 shows the last part of the path of the block before it hits the ground at point Y. At point X on the path, the block has a speed of 3.4 meters per second, means here the speed of the block is given, that is equal to 3.4 meters per second, and is at a height of 1.8 meters above the horizontal ground. So this is the height of this block above the ground at point X. For part C1, we need to calculate the decrease in the GPE of the block for its movement from X to Y. Means when the block moved from X to Y, how much GPE has been decreased. So pretty straightforward question. In order to answer this question, first of all, we can decide our reference line. So this is our reference line, and here we will take H is equal to 0. Now simply we need to calculate decrease in GPE, so we can write down delta GPE. This has to be equal to mg times delta h, mg is equal to the weight of the block, and weight of the block we have that is equal to 2.4 newtons, and height in this case delta h, this is equal to 1.8 meters. So the final answer is 4.3 joules. So this is our final answer. And this question has 2 marks. The first mark you will get if you have written this formula. You will get 1 C mark, and the second mark is answer mark. If you have got the right answer, you will get 2 marks. Part 2 says use your answer to C1 and conservation of energy to determine the kinetic energy of the block at point Y. At this point we need to determine the kinetic energy of the block, but we have the speed of the block at point X. Speed of the block was given, that was equal to 3.4 meters per second, and we have height of the block. And in this case there is no air resistance, mean air resistance is negligible, so it simply means that total mechanical energy is conserved. So we can say total energy, you can say, or we can simply say total mechanical energy at X has to be equal to total mechanical energy at point Y. And mechanical energy is the sum of kinetic energy plus GPE, means gravitational potential energy. And same for point Y, we can write down kinetic energy at point Y plus GPE at point Y. But for this question we have already discussed, we have taken ground level as our reference level, mean at this point we have taken height is equal to 0. As height is equal to 0, it simply means that GPEY, this is equal to 0. So now simply we can rearrange, we can write down kinetic energy at point Y. This one has to be equal to kinetic energy at point X plus GPE at point X. And for this question already we have calculated GPE at X, and GPE at X in the last part we have calculated, that was equal to 4.3 joules. We just calculated in the previous part, that was equal to 4.3 joules. So simply we can write down here, this is equal to 4.3 joules. Now simply we need to calculate kinetic energy at point X. We have the speed and we can calculate kinetic energy. Kinetic energy is equal to 1/2 mv square. So this is 1/2, and weight of this block we have, that was equal to 2.4, so we can divide by 9.81, so we can calculate mass, and we have the speed that is equal to 3.4 square of this one, plus we have 4.3. If we solve this one, we will get 1.4 plus 4.3, so the final answer will be equal to 5.7 joules. So our final answer is 5.7 joules. So this is how you can calculate kinetic energy at point Y, and this is equal to the total energy at point X. So this is how we can answer. And this question has 3 marks. The first mark you will get if you have written this formula, means you have used this formula, you will get 1 mark. And the second mark you will get if you have got this value right. So this is C1 mark. And the final mark is the answer mark. If you got the right answer, you will get 3 marks for this question. Third part says state the variation, if any, in direction of acceleration of the block as it moves from X to Y. So acceleration is due to gravity, and only force acting on the block is gravity, and gravity is always acting downwards, and acceleration and resultant force, they are always in same direction. So it means that as direction of gravity is not changing, so direction of acceleration is also not changing. So simply we can say in this case no variation. No variation because acceleration is always in this case vertically downwards. So this is how you can answer. Acceleration is always vertically downwards, and this question has only 1 mark. If you have written this one, you will get 1 mark, and this one should be B mark. Part 4 says the block passes point x at time tx and arrives at point y at time ty. On figure 2.3, sketch a graph to show the variation of the magnitude of the horizontal component of the velocity of the block with time from tx to ty. Numerical values are not required. So for this question, we need to understand, we have discussed already that only force acting on the block is gravity, and gravity is always vertically downwards, and there is no component of gravity along x-axis, along horizontal. So it simply means that as there is no force along horizontal, so the horizontal component of velocity will remain constant. So let me explain you this one with this small diagram. So we have velocity in this direction at point x. It has two components. One is the vertical component, so this is vy, and the other component it has, that is vx, and vx remains constant because gravity is only acting vertically downwards. So it means horizontal component of velocity will remain constant. So simply we need to draw horizontal line. So this is how you can draw the horizontal line, and this question has only 1 mark. If you draw this horizontal line, you will get 1 mark. Question 3 says a block is pulled by a force x in a straight line along a rough horizontal surface as shown in figure 3.1. Assume that the total resistive force opposing the motion of the block is 0.80 at all speeds of the block. The variation with time t of the magnitude of the force x is shown in figure 3.2. So here we have force, first of all 1.4 newtons, and then force decreases to 0.80 newtons, but it stays constant for this period of time, and force also stays constant up to 3 seconds. So if we draw the line, so here we have 3 seconds. Before 3 seconds, force is equal to 1.4 newtons, and after 3 seconds, force is equal to 0.8 newtons, 0.8 newtons. And for this question, we need to define force. What is force? Force simply is equal to rate of change of momentum, means the resultant force, this is equal to rate of change of momentum. And this is very common question, so you need to understand how to define force. So simply we can say force is rate of change of momentum. So we can write down force is rate of change of momentum. And this question has only 1 mark, and this is B mark. If you write down this, you will get 1 mark. For the second part, we need to determine the change in momentum of the block from time t is equal to 0 to t is equal to 3.0 seconds. And net force, we understand that net force is equal to rate of change of momentum. And for this question, we need to determine change in momentum. So the change in momentum is equal to F net times delta t. If you look at this given graph, we can find the applied force from here. Applied force is equal to 1.4 newtons until 3 seconds, means up to this point force applied is 1.4 seconds. Then there is also frictional force that is acting on the block. So the resultant force is applied force minus friction. So we have minus friction, and duration of time is given, that is 3.0. Now simply we can plug in values. We can say delta P in this case is equal to net force, that is 1.4, minus the friction, that is 0.8, multiply by the time we applied force. So beauty of this one is, if you throw something like this, change in momentum will be small, but if you throw something like this, change in momentum will be greater because you apply the same force for longer time, same net force for the longer time, so change in momentum will be greater. So time is given to us, that is equal to 3 seconds. So if we multiply, we will get 1.8 kgs meters per second. The beauty of physics, physics in action. If you throw something like this, change in momentum will be small if for the same applied force and shorter period of time. And if we apply the same resultant force but for longer period of time, change in momentum will be greater. So that's the reason when we throw something, we throw like this. We not just throw like this. Very important, very practical point. So answer for this question is 1.8. 8 kgs meter per second. So if you have written this equation, you will get 1 C mark, and if you got the right answer, you will get 2 marks. Part B1 says describe and explain the motion of the block between time t is equal to 3.0 seconds and t is equal to 6.0 seconds. So if you look at the force, applied force on the block in this interval of time, applied force is equal to 0.8 newtons. On the block we have applied force x, so we can say this is over x force, and this is equal to 0.8 newtons. And also there is friction, and frictional force F is also equal to 0.8 newtons. It simply means that resultant force on the block is equal to 0. So as resultant force is 0, we can write on here as resultant force is 0 on the block is 0. So velocity remains constant. So velocity remains constant. So this is how you can answer. This question has 2 marks. So it has 2 B mark. One for writing resultant force is 0, and second for writing velocity remains constant. Means magnitude and direction of velocity remains constant. Part 2 says force X produces a total power of 2.0 watts when moving the block between time t is equal to 3.0 seconds to time t is equal to 6.0 seconds. Calculate the distance moved by the block during this time interval. So for this one, first thing we need to understand that power is equal to Fv. So from here we can calculate value of V. V will be equal to P divided by F. So we have value of power developed, that is equal to 2.0 watts, and the force between t is equal to 3.0 seconds to t is equal to 6.0 seconds. Applied force is equal to 0.8. So we can calculate value of V. So value of V in this case will be equal to 2.5 meters per second. Now we have value of V, and the block is moving at a constant speed because there is no resultant force. So simply we can say distance has to be equal to V times t, because speed is constant. So speed is 2.5 and the time interval is 3.0 seconds. So the final answer has to be equal to 7.5 meters. So this is how we can answer. So simply we can say final answer is 7.5 meters. And this question has 3 marks. So the first mark will be for writing this formula, C1 mark, and the second C1 mark will be for calculating value of V, and the final mark will be the answer mark. Part C says the block is at rest at time t is equal to 0. On figure 3.3, sketch a graph to show the variation of the momentum of the block with time t from time t is equal to 0 to t is equal to 6.0 seconds. Numerical values of momentum are not required. For this question, first thing we need to understand, we have momentum on y-axis and we have time on x-axis. So the gradient of this one, so the gradient of this graph has to be equal to delta p by delta t, and this gradient is representing net force. For this question we need to understand, for interval from t is equal to 0 to t is equal to 3 seconds, we have x that is equal to 1.4 seconds. So we can say t is equal to 0 to t is equal to 3.0 seconds, and the net force we have for this interval of time, that will be equal to 1.4 minus 0.8 friction, so that will be equal to 0.6 newtons. And for interval we can write down, for t is equal to 3.0 to 6.0 second, F net is equal to 0. So it means that in the first interval, gradient has to be equal to 0.6, gradient has to be equal to this one, and in the second interval gradient has to be 0. Gradient has to be 0. And for this question we don't need any numerical values, So simply we can sketch this one. We can start from origin because initial momentum is 0, because initial velocity is 0. So up to 3 seconds. So we have 3 seconds here, up to 3 seconds. Gradient has to be constant because resultant force is constant, and after that resultant force is 0, so the gradient has to be 0. So this is how we can sketch the graph. Question 4 says a spring is suspended from a fixed point at one end. The spring is extended by a vertical force applied to the other end. The variation of the applied force with the length capital L of the spring is shown in figure 4.1. For the spring, state the name of the law that gives the relationship between force and extension. So that is Hooke's law. Pretty straightforward question is asking you to write down name of the law, and name of the law is Hooke's law, mean F is directly proportional to minus X. So this law is Hooke's law, and this question has only 1 mark. If you have written Hooke's law, you will get 1 B mark. Part B says determine the spring constant in newtons per meter, and spring constant K is equal to force divided by extension delta X, or simply for this graph we can say it is also equal to the gradient of this graph. So simply we need to calculate the gradient. We will be taking this point and we will also consider this point. So the force in this case, we have 12, this is 12.0 minus 0 force divided by, we have maximum extension, that is 24 centimeters, minus we have the initial length, that is equal to 8, but the units for this one is centimeters, so we have to convert into meters. And now if we solve this one, our final answer up to 2SF has to be equal to 75 newtons per meter. So this one is the final answer, and this question has 2 marks. The first mark you will get if you have written this one, so this one will be 1 C mark, and the second mark should be the answer mark. Part C says determine the elastic tension energy when F is equal to 6.0 newtons. So first of all, it is given to us that F is equal to 6.0 newtons, and from here we can find the extension. So from here we can find out extension. We need to calculate in this case delta EPE, means the change in elastic tension energy, and change in elastic tension energy will be equal to the work done by applied force, and work done by applied force will be equal to the average force, because in this case force is not constant, times distance. So F average we can write down, this will be equal to F max plus 0 divided by 2, because force started from 0, times distance d. Distance d will be equal to x, means equal to delta x extension. So this is our extension. So simply we can write on here, we have 1/2 F max times we have delta x, and value of F max we have, that is equal to 6.0 newtons, and we can find out delta x, 16 minus 8. 16 minus 8, it means we will get 8.0, and this will be multiplied with 10 to minus 2, because this is given in centimeters. So if we solve this one, our final answer will be equal to 0.24 joule. So this is the final answer, and this question has 2 marks. The first mark you will get, that one will be the C mark. If you have written this equation, means this one if you have written, you will get 1 mark, and this one will be the answer mark. If you got the right answer, you will get 2 marks for this question. That's all for this video, and we have discussed all questions about mechanics in today's lesson. And in the next lesson, we will discuss remaining questions about waves, electricity, and radioactivity from this paper. See you in next video.